This is homework 10, question 2 for probability and stochastic. And for question 2, ask about the definitions or properties of stochastic process. And for subproblem 1, it is y-sense stationary process. We call WSS. So WSS only uses mean and autocorrelation, and its mean is a constant and the autocorrelation is a function of time difference. And for subproblem 2, it asks about independent increment process. So x of t1 minus x of t2 and x of t3 minus x of t4 on non-overlapping intervals are independent. And for subproblem 3, I ask about Markov process. So Markov process actually used in many real process. Many process has Markov properties. So x of t is a Markov process if the past has no influence on the future when the present is known. And for subproblem 4, so normal process we also can call Gaussian. So a process is to be normal if the random variable x of t1, x of t2, and x of tn are jointly normal for any n, for any t1, t2, and tn. So we can write that f of x bracket x1, x2, and xn. So t1, t2, and tn, it is equal to 1 over square root 2n to the power of n, square root detect c times e to the power of minus half times x minus mean n, so to the power of t, c to the power of minus 1 times x minus mean, where x is equal to bracket x1 and xn, and capital X is equal to x of t1 and x of tn, and mean is equal to e of x. The autocorrelation is equal to mean e of x minus mean times x minus mean to the power of t. And for the fifth, it is called a strict sense stationary process, and it says a process is said to be a strict sense stationary process if it is not affected by any shift on the time axis. And for the sixth, white noise. So for Vienna process, W of t, the derivation of it can be written as d of w of t divided by dt is equal to v of t. So we can write v of t. And e of v of t is equal to 0, and the autocorrelation r of t1, t2 is equal to alpha times delta t1 minus t2. So we use d omega of t, d w of t times w of t, so it is continuous with probability 1, and then do the differentiation of it. So d of w of t times v of t is equal to dw of t divided by dt. So it is Gaussian white noise with 0 means and impulse autocorrelation function. And v of t is a stochastic process. So it is to be a white noise if e of v of t is equal to 0 and autocorrelation of t1, t2 is equal to q of t1 delta t1 minus t2. And for the seventh, mean ergodic process. So a stochastic process x of t is a mean ergodic process if limitation t is going to infinity 1 over 2t integral t minus t to t x of t dt is equal to e of x of t in mean square sense. And for the eighth it asks about martingales. So martingales, if e of x of t given x of s is equal to x1 where s is less or equal to t, and e of x of n, e of absolute value x of n is less than infinity.